All right, so we're going to find some special points that lie on the unit circle. So first of all, what is the unit circle? So a unit circle has two characteristics. First of all, it's centered at the origin. Okay, so notice I have the X and Y coordinate plane here. My circle is centered at the origin. So the center of my circle is at the origin of the XY coordinate plane. The radius of a unit circle is 1. That's what unit means, 1. So the radius is 1, and it's centered at the origin. So right off the bat, we can find 4 really simple points. So what is the coordinates of this point on the circle? Well, that's really easy. If it's on the XY axis and the radius of my circle is 1, then this distance is 1. So the X value should be 1 and the Y value should be 0. So this point on the circle is at the point 1, 0. Okay, what about this point? Well, obviously this point is 0, 1. This point is -1, 0. And this point would be 0, -1. So 4 really easy points that we can find right off the bat. All right, now let's think about the coordinates of this point. What would that be? All right, so this angle, we're going to say is 30 degrees. So this guy right here is 30. So the trick here to figuring out the coordinates of this point is we're going to drop a perpendicular here, which makes that a right angle. So I've just drawn a line that goes straight down from this point to the x-axis, which makes this a right angle. Well, if this is 90 degrees and this is 30 degrees, then this angle should be 60 degrees. Right, in the previous lesson, we learned about the relationship between the sides of a, this is not what I wanted to do. I don't know why. Scratch everything I just did there. I don't want to do that yet. This is 45 degrees. I'm starting at 45. Good grief. I drew that right at the middle. I meant it to be 45. All right, so if this is 90 and this is 45 degrees, then this is also 45 degrees. Sorry about that. All right, but again, we learned the other day about the relationship between the sides of a 45, 45, 90 degree triangle. So, really simple. How long is this hypotenuse? Remember the characteristics of a unit circle. The radius of the circle is 1. So this distance from here to here should be 1. All right. So the relationship between the sides of a 45, 45, 90 degree triangle is this side is the square root of 2, square root of 2 over 2 times the hypotenuse, but my hypotenuse is 1. So the length of this side of the triangle should be the square root of 2 over 2. So from here to here is the square root of 2 over 2. Well, if that's the case, this line goes straight up, then the x-coordinate of this point should be the square root of 2 over 2. What about the y-coordinate? All right, so remember that this side of the triangle is also the square root of 2 over 2 times the hypotenuse, which is 1. So this side is the square root of 2 over 2 units long. Okay, so if this side of the triangle is square root of 2 over 2, then the y value of this point would be the square root of 2 over 2. Okay, so we know the coordinates of this point on the unit circle if this angle is 45 degrees. All right, let's find the coordinates of this point that's created by this 30 degree angle. So now I'm doing the 30 degree angle that I wanted to do a minute ago. Okay, so 30 degree angle, I want the coordinates of this point. So I'm going to try the same trick. I'm going to drop a perpendicular. which makes that a right angle. So now I have this triangle that's 90, 30, and 60 degrees. Okay. And again, we know the relationship between the sides of this triangle. First of all, the hypotenuse is 1 unit long because this is a unit circle. The side opposite of the 30-degree angle is 1/2 times the hypotenuse, which in this case is 1. So the length of this side of the triangle is 1/2. Okay, so if this distance is 1/2, then the y-coordinate of this point should be 1/2. The side opposite of the 60-degree angle is the square root of 3 over 2 times the hypotenuse, which in this case is 1. So this length would be the square root of 3 over 2, which means the x-coordinate of this point would be the square root of 3 over 2. All right, what about the coordinates of this point that's created by this 60-degree angle? So 60-degree angle from the x-coordinate up to this line. So this is a 60-degree angle. What's the coordinates of that point on the unit circle? So again, I'm going to do the same trick. I'm going to drop a perpendicular, create a 90-degree angle. So this is 90, this is 60. So this angle has to be 30 degrees. All right. The hypotenuse of this triangle is 1 because this is a unit circle. So the side opposite of the 30-degree angle, so this side of my triangle is the square root of 3 over 2 times the hypotenuse, which is 1. So this side is the square root of 3 over 2, which means that the x-coordinate of this point, what did I do? All right, sorry about that. I'm completely losing focus here, apparently. That is not right, what I just said. Let's try this again and see if I can pay attention to what I'm doing. The side opposite of the 30-degree angle is 1/2 times the hypotenuse. So 1/2 times 1. Got to keep those straight. You got to make sure you remember the relationship between that. Also know where we got it from so that if you forget, you can go back and derive it. So the side opposite of the 30-degree angle is 1/2 times the hypotenuse. So the length of this side of the triangle is 1/2, which means that the x-coordinate of this point is 1/2. All right, what about the y-coordinate? Okay, so I want the y-coordinate of this point. Okay, so I need to know how long this side of the triangle is. Well, the side opposite of the 60-degree angle is the square root of 3 over 2 times the hypotenuse, which is 1. So this side of the triangle is the square root of 3 over 2 times 1, so it would be the square root of 3 over 2. All right, so we found the coordinates of, the crows are back. So we found the coordinates of these 3 special points in the first quadrant. Crazy crows, bells ringing. All right, so these 3 special points in the first quadrant here. Remember, I'm writing the 30 degrees, the 45 degrees, and the 60 degrees up here, but remember what those mean. This 30 degrees applies to this angle. This 45 degrees is this angle. This 60 degrees is this angle. Okay. 90 degrees would be this whole angle from here to here. All right. Also notice that the pattern that we have, this is 30 degrees. and then it's 15 more to get to 45. Then it's 15 more degrees to get to 60, and then it's 30 again. So we go 30, 15, 15, 30. And we're going to do the same thing all the way around the circle. So 30, 15, 30, 50, try again. 30, 15, 15, and 30 more. So we'll do the same thing. We'll go 30 degrees here. So this angle will be 120 degrees. And then 15 more, so this would be 135 degrees. 15 more, this would be 150 degrees. And of course, this would be 180 degrees all the way around to a straight line. Okay, so make sure you understand what this 120 that I've written up here in a strange place actually means. It means this angle from here all the way to here. So it's this whole angle right here from the x-coordinate rotated counterclockwise to right here. That's 120 degrees. All right, so we want to find the coordinates of this point. So we'll try the same trick again. So I'm going to drop a perpendicular. I'm going to get rid of all this mess right now. We'll put it back. We drop a perpendicular. That makes our right angle. All right. So let's think about this now. So this angle from here all the way to here was 120. So what is this angle right here? Well, the whole thing's 180. So if it's 120 from here to here, that leaves 60 degrees for this whole angle right here on the triangle. So make sure you see the triangle I'm talking about. So from here, out this way, and up here. So this whole triangle. Okay. This will be 60 degrees, which means that this is 30 degrees. So my hypotenuse, again, is 1. So the side opposite of the 30 is 1/2 times 1. So this would be 1/2 this distance. So this is the x-coordinate of this point. Okay, so the x-coordinate would be 1/2. But now think about what we're doing. This is a unit circle, so it's sitting on the xy axis. Remember that out this way, the x values are negative. So this distance is 1/2. But since it's to the left, the coordinate of this point would be negative 1/2. All right. What about the y value of that point? So that would be this side of the triangle, which is opposite the 60. So it would be square root of 3 over 2 times 1. So it would be the square root of 3 over 2. Here in the second coordinate, my y values are positive, so that should stay positive. Okay, so all these points in the second quadrant will always have a negative x value and a positive y value. All right, so we can continue around the circle and keep drawing these triangles, but there's a quicker way of doing this if we think about it and we're smart. Notice that it's 30 degrees from here to here. It's 30 degrees from here to here. So these points, now those crows are right in my face. They really want to learn trig. All right, so it's 30 degrees from here to here, 30 degrees from here to here. So these points move the same distance out the circle, around the circle. So you can see that these numbers should be the same for both of those because they both go the same distance. So they both have a 1/2. They both have a square root of 3 over 2 for the x and y values. The only difference is the sign. So we could keep drawing triangles all the way around the circle, but we don't have to. We can use the symmetry of the circle to make that happen. So let me get rid of some mess here. All right, so what about this next one? The next one would be 135 degrees. So from here to here is 135 degrees. What's the coordinates of this point? Well, this matches up with this point. Okay, so it's 45 degrees from here to here. It's 45 degrees from here to here, so the numbers should match up in those 2 points. The only difference will be the sign. So this should be negative square root of 2 over 2. and this will be positive square root 2 over 2. The same here, these points match up. So this would be negative square root of 3 over 2, and this one would be positive 1/2. All right, so you should now be able to fill in the coordinates of these 6 remaining points here. And these will be the only 3 that you'll be able to figure out. And the pattern of angle measures are the same right here. So use the same pattern. You'll come up with 3 angle measures that you know how to find the coordinates of. So do that here and do that here. And you can either draw triangles or you can use the fact that this circle is symmetric. But find the coordinates of these 1, 2, 3, 6 remaining points.